let's continue with question 18. Very similar to question 17, except for one crucial piece of information, and that is the state of things. So I'm just going to start reading it. 0.200 gram of butane. So mass of C4H10 is 0.200 grams. It's burned completely in excess oxygen. So this is another combustion reaction, producing carbon dioxide gas and water vapor. So they're actually telling you what the states of everything is supposed to be. And 9,914 joules of energy. Use this information to write thermochemical equation. I'm just going to start with the equation. So I just want to see where things are, things like that. So let's go with C4H10. Now, if you check the data book, it's a gas. So I'm going to go with that because the question doesn't tell me. So they can't penalize me. I don't think butane exists. Oh, it does liquefy gas, so maybe not. Producing carbon dioxide, so CO2, and water vapor, so H2O gas. Okay, we're going to balance this, so I think I'm going to need to put a 2 here, and an 8 here, and a 10 here. So we have 13. This is not yet a thermochemical equation. I need to find the delta H value, which essentially means that I need to find energy release. Once again, this is an exothermic reaction. But if you are going with this particular if you're going with this particular equation, it's energy release per 2 mole of butane. That is the unknown here. Okay. Now the question gives you 2 grams, 9,914 joules of energy is released for every 0.2 grams of C4H10. So this is given, which means I need to convert this ratio to an energy per mole of butane ratio. So I'm going to try to find number of mole of butane, which is mass over molar mass, which is 0.2 over 58 equal to something 0.00345 mole. Okay, so that's the number of mole. So now I can change my ratio to E release, which is what I'm after to get the delta H value, per 2 mole is equivalent to 9,914 joules per 0.00345 mole. Okay, so energy release is going to be 2 times 9914 over 0.00345 times 2. So I have, it's a huge number. We're going with 3 sig fig, I think, so 5.75 times 10 to the power of 1, 2, 3, hang on, 1, 2, 3, 4, 5, 6, negative 6 joules. You don't necessarily have to convert it to kilojoules, to be honest. You can leave it as joules. As long as it's correct, it's fine. Final answer, 2C4H10 gas plus 13 oxygen going to 8 CO2 and 10 H2O with a delta H value of negative 5.75 times 10 to the 6 joules per mole. Well, that is absolutely all the space that I have, so I hope everything sticks. That's it for question 18.